Welcome to an introduction to derivatives. This is my first video on this chapter, and it'll probably be the only video that has a lot of theory compared to examples. I just want to lay down some underlying theory, pretty basic theory on what the derivative is, why we take it, how we take it, just some stuff that's going to help you when solving future examples. So let's get started. So let's say we have a function and we want some information from this function. What are we going to do? Well, we're going to take its derivative. And by taking its derivative, I just mean we're transforming it using a set of rules. And we're going to say that the first rule is that the derivative of a constant is equal to 0. Now, the derivative is just something we use to get information from a function. So we're going to say that f of x is equal to 3. And we want some information from this function, so we're going to derive it based on a rule set. And by doing this, we transform it into a new concept. We transform it into its derivative. And we denote this with f prime of x. And why have I put f prime of x equals to 0 and not f prime of x equals to 3? Well, if we go back to the rule set here, d over dx of c equals to 0. What does that mean? You might be saying, why aren't you canceling the d's? What are you doing? Well, this d over dx is actually just the derivative operator. And that is just saying we're taking the derivative of whatever's in that bracket. And this c just represents a constant. So it's saying that the derivative of a constant is equal to 0. So when we take the derivative of f of x equals to 3, we denote the derivative with this little prime symbol here. It shows that we've taken the derivative, and we know that the derivative of a constant is equal to 0. So that's all we've done. We've transformed a function into its derivative using a set of rules, and we're doing this to get information. About that function. Now, you may be asking, well, what information are we getting about the function? If we have an axis and we graph our function, f of x equals to 3, what does it look like? Well, it looks like a horizontal line at y equals to 3. And that's all it is. And we know intuitively that the slope of a horizontal line is 0, right? The rise over the run, the y2 minus y1 over x2 minus x1 is 0. There's no slope. So when we take the derivative, we also notice that f prime of x is equal to 0. Well, the information that the derivative gives us, it gives us the slope of the function at every point. It gives us a formula for the slope. We don't have to do the individual computations at every point. We can just plug in values into that formula and we can get the slope. And we know any value we plug in there is going to come out as 0, right? Because the slope at every point on this line is 0. So if we have f of x and we derive f of x, this d over dx, remember, it's just the derivative operator. It's just telling us that we're taking the derivative. It transforms into f prime of x. And that little prime symbol just denotes the first derivative. Now, what happens if we derive it again? Well, when we derive it again, we get the second derivative. We get f double prime of x. And if we derive it again, we get f triple prime of x. Now, why would we do this? Well, we know that f prime of x gives us further information about the function. We know it gives us the slope at every point because it provides a formula where you can plug in any point into it, and it'll give you the slope. Well, what is f double prime? When we derive again, f double prime gives us further information. F triple prime gives us further information. And that's all we're doing. We take a function and we want information from it, so we derive it using a set of rules. Notation. Don't be confused by notation. I denoted the fact that, so let's say we have f of x equals to 3. And we derive it. You guys know this already, that we get f prime of x equals to 0, right? Well, there's other ways you can represent this. This means the same thing as y prime of x equals to 0, and it also means the same thing as dy over dx equals to 0. These all represent that we've taken the first derivative of the function. They all mean the same thing, so don't get confused by them. You can write it however way you like. I prefer to write it like this, well, f prime of x, when I'm doing examples and when I'm teaching it, but you guys can do whatever you want. I think that concludes the video. Just make sure to subscribe, like the video, do all that stuff. And if you found this helpful, go watch my continuation of this video. I'm gonna do, you'll see that I've done all of the rules and dove into some applications in engineering, economics, business, etc. Thanks for watching, and have a good rest of your day.